Okay, so welcome students. Let's try this again. Hi guys, this is going to be our last video for the semester, okay? And we are going to learn how to find sums of infinite geometric series. So what we're going to do is talk about some homework examples, and then hopefully get a little bit more information about how series work and understand the difference between sequences and series, okay? But for now, let's get started on these homework examples. Now, the first thing we're going to need to know is the formula for the sum of infinite geometric sequences. Now, it's really important that you look at the way that it's written, okay? It says if the absolute value of r is less than 1, then the sum of the geometric series converges to the sum s is equal to t sub 1 divided by 1 minus r. Now, this is an important theorem because it's really loaded with a lot of information because of this word right here. Because when we start talking about converging to a particular number, right, that starts to sound like a limit of a sequence, okay? So when we're talking about series, right, we have to understand that a series is just a sequence, except now we're just adding all the terms together, right? So when we're talking about this word converges, it really packs a lot of information into it. It would take us, a whole lecture on its own to talk about how convergence relates to sums of geometric series. But in our case, the only thing I'm really concerned about right now is using this formula right here. Okay? So basically, what we're going to do is we're going to find the sum of this series right here. So, homework example 1, we have the series 9 minus 6 plus 4 minus ... So, what we have to do, if we're going to find the sum, we need to know the first term, and we need to know what r is. So T1 is given to us, and it's 9. Now, to find the sum of a geometric sequence, what you have to do is you take the first and second terms and divide them, okay? So r is equal to t sub 2 divided by t sub r, or t sub 1. And in this case, we're going to have negative 6 divided by 9. Negative 6 divided by 9. And that reduces to negative 2/3. So now we have t sub 1 and we have r. And what we do now is we say, okay, 9, right, is a t sub 1 minus 1 minus 2/3. So that's r. This then becomes 9 over 1 plus 2/3, which gives us 9 over 5/3, which is equal to 9 times 3/5, which is 27 over 5. So the sum of our infinite geometric series is going to be 27 over 5, okay? Now, when it comes to this example, right, we have to really pay attention to what we need. We need t sub 1, and then we also need r, okay? So let's try the next one. We have our sequence, or our series, 1 plus 1/3 plus 1/9 plus dot, dot, dot. So our first term, t1, is 1. Our ratio is going to be 1/3 because we take 1/3 and we divide by 1. So then we just say our first term, 1 over 1 minus 1/3 is equal to 1 over 2/3. 1 over 2/3, that means we just take the fraction and we reciprocate it and we get 3/2. So when we're finding sums of infinite geometric series, all we're going to do is use this formula here and making sure we understand how to find T1 and how to find R. It's pretty simple. Now, our next homework example though, we are going to need a little bit of explanation, or we have to go back and read our theorem. Okay, so for this next homework example, we're going to talk about this question here. It says, for what values of x does the series converge? Okay, so we have this series, it's a geometric series, okay, where we have 1 plus x plus 2 plus x plus 2 squared plus x plus 2 cubed. So if we were to find the values of x where the series will converge, we have to go back to the theorem, okay? Because remember, we have this convergence right here, right? When will our series converge, okay? The only time that this series will converge is if our ratio is less than 1, okay? So this is the prerequisite for converging sums or finding sums of geometric series, okay? So the important thing is looking at your fraction or your ratio, your common ratio. So whenever that ratio is less than 1, the series will converge, okay? If it converges, then all of a sudden we can find the sum, right? So likewise, conversely, right, if it doesn't converge, if it diverges, that means the sum will either go to infinity, negative infinity, or they'll approach two numbers like we were talking about when it comes to limits, okay? And that's why I was talking about this idea of convergence was really gonna be, it's compact with a lot of information. But in our case, all we have to do is say, okay, so for what values of x does the series converge? Okay, so that says when r, the absolute value of r, is less than 1. That's the general understanding. That's the basis of what we have to do. Then we have to say, okay, now we have to find the values of x, right? All right, so what values of x do we have to use? First, we have to find r, okay? So for this sequence, 1 plus x plus 2 plus x plus 2 squared plus x plus 2 cubed. So we have to find r. So we take our second term and divide it in by our first term, right? X plus 2 divided by 1. So R ends up being X plus 2. So now we know what our ratio is. Now we can say, okay, when this thing is less than 1, that's when our series will converge. So we say, okay, the absolute value of X plus 2 of R is less than 1. Then we're going to substitute this in for R because that's what our ratio is. So we have X plus 2 is less than 1. So now when we're finding absolute values, right? So when we're trying to find absolute values, we take X plus 2 equals positive 1, and then X plus 2 equals negative 1, because we're solving the inequality. Then we say we subtract 2 from both sides, we get X plus 2 is equal to negative 1, and X plus 2 is equal to negative 3. So whenever X is negative 1 or negative 3, so that's when our series will converge, right? Here we go. So whenever X is between negative 1 and negative 3, whenever X is between the interval negative 3 and negative 1, the geometric series will converge. Okay, so what's important to understand about this is this interval is called the interval of convergence. Okay, so this thing is the interval of convergence. So whenever we're trying to find the interval of convergence, we're actually answering this question, right? For what values of X does the series converge, right? What we have to do is we got to find R, set it less than or equal to 0, the absolute value of R less than or equal to 0, and then we find that interval. And that's it. So our homework question, we will be looking for intervals of convergence. Also, we will find the sum of this sequence, right? So if we're looking for the sum, we take our first term, which is 1, and then we subtract off our ratio, right? So 1 minus R, which is going to be X plus 2. Then we just solve this algebraically, right? So this becomes 1 over 1 minus X minus 2. All I'm doing is distributing the negative sign to the X and the 2. Then I simplify this and I get 1 over 1 minus 2 is negative 1, X minus 1. And there's my sum, okay? Hopefully that gets in the screen. If not, then we'll have to adjust that. So when it comes to our second homework question, right, we're finding intervals of convergence, and then we're also finding sums, but our sums are going to be in terms of x or n. They're going to be general sums. Okay, so you're going to have equations and things like that, or expressions. Move this over so that you can use that for your notes.